Hey everybody, I'm Michał Papis, Michał, or as you say, Misha. But it's easiest if you call me Michael. I probably wouldn't even turn over if you call me Michał. So you can find me on Twitter, on GitHub, and I'm currently working with Concilion just for a week now. And we are doing this small thing. I'm not sure if you see it right here. It's the bluish thing. It's for ink. They do printing for students, only in America, of course, because they pay. But we will be doing a talk today about Ruby, which means object-oriented Ruby. And you must be asking why, because there is a lot of resources already. A lot of people wrote books, a lot of people said things about object-oriented Ruby, how to do it good, how to write better code, and why somebody is repeating it again. Why? Because people are still breaking encapsulation. And even if we are provided with rules, how to write better code, how to write code that doesn't break encapsulation, with rules which make you write better code, you still don't have good explanations what encapsulation is. So I want to go over encapsulation, show up what encapsulation is, give you an idea what it does for you. And there is another point. Almost nobody uses inheritance. I know some people discourage it, but sometimes it's really useful. And sometimes it even fits what we want to do. So inheritance is called evil by some people, especially if you speak with people from Java. But still, inheritance is sometimes useful, and you should know when to use it. And there's another point, immutability. People read about functional languages, and they think, oh, that's great. Everything will be so clean, I won't change anything, and they force immutability. And then guess what? Ruby has garbage collector, and when you write big enough application, garbage collector kicks in. Your application gets really slow, and then you think how to remove immutability. But you already wrote it, so you are producing more work. So if you get back to encapsulation, you could probably prevent some problems with immutability. You probably could skip it because you could write better code. So what is encapsulation? I was thinking really hard because how to explain encapsulation? This is really complicated thing. It's so simple and so complicated. And then, you know, this bulb happened, and yeah, I know. Yeah, this is the best example of encapsulation. Most of you use it, even if it's not the real calculator, it's the app on your computer. And this app, or this hardware, represents encapsulation, because everybody knows how to use it, people use it, but most people don't know what's inside. They don't care. You got input, you push some buttons, everything works, and you get some output. So you see the results. Depending on what you push, you get different outputs. And you don't care how it happens. You just want to get the result. This is encapsulation. There's another part, documentation. With the calculator, you get documentation. It's really part of encapsulation. If you want to have encapsulation, you need to provide description of the interface. There is output, input. You need to say what they do, how to use them, so people don't have to go inside and break those things, because there is something inside. And some people know how to play with it. Some people designed it, so they have to know what happens inside. And some people know how to use soldering iron, and they want to just dig in. But if you sometimes playing, you don't have enough knowledge, these things happen. You just get a big mess, and then you have to put this sticker, don't touch it, right? So although you could play with calculator, you can go inside. Probably nobody knows how to use it after you change it. That's encapsulation. And the first problem I see when I think about code, and when I look into other people's code, it's how they abuse mixins, how they do encapsulation in mixins. And this is how functional programming fits in. You can actually write functional code, and mixins really fit in. If you get patterns, things repeat, 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 you start writing the same functions to handle it, so you can reuse it. But you have to be very careful. We got the first example. So you can see we got a config file name, and we got the config. It's great. You just extracted something that you are repeating again and again, all around the code base. It happens everywhere. Is it great? No. You have no clue if this config file name will be defined. It can be there. It doesn't have to be there. Do you have documentation for it? Do you know what's going on? Even worse, look at the config. It will be only set if it wasn't set yet. So if another module defines config, which does something different, doesn't have to be the same thing, here we are assuming it's array of lines, but maybe it will be a hash. It's totally different interface. So we are changing here instance variables, and we are assuming there will be some variables. There is no way to check it. How this could be done better? No instance variables. Because in mixins, instance variables are your enemy. You shouldn't use them. If you use instance variables, there is no interface. You cannot describe what's your input, what's your output, how it behaves. It's purely functional. If you take away that the read lines can do something with file system, it takes the input and provides the output. Another example, and you would think, oh, nothing wrong can happen. But again, the birth date, it can be a day, it can be a date, maybe it's an active record. It can be anything in the system. If we pick instance variables in our mixins, we are doing something wrong because it's bad. And I was actually writing code recently that needs to do that because I was forced to do that. Because the interface I was working with, RSpec doesn't allow us to do it better. I had to dig in and had to modify it. So I hate to change the instance variables because I know something wrong can happen. And there is a better way. There is composition. If you started to write mixins that already do something, like this small thing with birthday, this is where composition would fit, because it actually would be a simple object that you can embed in another object. And with composition, it will be great. But what the composition is? We know that there is a world, like whole galaxies. And they have some planets, some suns, some life forms. And those life forms go into atoms. So we can think from the smallest to the biggest imaginary things described. You can go from the smallest abstraction level to really big abstraction where this small atom goes into beings, planets, and then galaxies. So abstraction here allows us to build composition. From atoms, we build creatures. And this is a bit bigger example. Is it readable? Yeah. Oh, I was really thinking it won't be. So I'm seeing this pattern a lot in code. So somebody had to change the color. So they implemented a barber because barbers change the color. And this is, look where it is. It's not even separate class. It's inside of the person. Of course, because it only works with person. So I see this code repeating a lot. And there is a lot of bad things here. And this example code here shows you what can happen. Because we have no protection. We can do anything we want. We just built a helper class, and people can change it. And in this example, I know color and name, that's not so easy. But assume we will have status X, status Y. Things get complicated. That's easy to mess up. And this shows you how this would be wrong. We could do it better. This composition was done wrong. Oh, yeah, next example. And here we try to do it better. We define hair, we define barber separately, and the person can take the barber in dye hair and take the color, and the barber will be only allowed to change the color. It will be allowed only to work on the hair. So with composition, with building more objects, you're allowed to just virtualize it. Only small part of the person will be allowed to change for the barber. And we can see we got the right color on the end. But nothing else can happen. Of course, this can be more complicated because the barber will be having this a lot complicated method that depending on the colors, you get different results. Maybe if you use white, it's always white on the end. Oh, again, wrong button. And then I want to tell you about inheritance, because sometimes it's really useful. And you have to think about it. But liars, where are we? Inheritance. Yeah. Inheritance is like liars. So you can build on top of previous functionalities. But liars aren't like, do whatever you want. It has to be the same kind of thing. If it's onion, it will be still onion if you build on top of it. And we have really nice example where we have a person and then we have a superhuman that is just stronger and of course can fly. And this is where inheritance works, because superhuman is just kind of human of the person. It doesn't work always. Sometimes it's better to use composition. And if you are in doubt, probably you should use composition. But sometimes if it's actually the same thing, if you are still extending person, then it might make sense to use inheritance. So that was quite short, and probably some of you already read my article. But I'm working on next things, and I want to work on typed Ruby next. And I've already started sketching it. So for sure contracts, because if we are talking about types, I want to include contracts. Contracts allow you to put a contract on top of a method, describing what are the inputs, what are the outputs, and when something is wrong, you get exception in this place. Think of it as tests at runtime. You get a set of tests checking if the input and output is always right, and when it isn't, you get exceptions. So you know in this place something was messed up, not somewhere else. It doesn't bubble further to another 20 places. But there is another thing about types. And we already mentioned it minimally in earlier interfaces. And you would wonder, you cannot have interfaces in Ruby. Actually, you can. It's not the real interface, but you can build one. You can build a new object that only forwards the method that you want it to use. So you can limit the interface. If you have an object that has setter and getter to set values and to read them, you might want to only export the interface for reading. So you build a new object that only forwards the reader, and you pass on the reader. This way, you can achieve interfaces, and then you can achieve security. No, of course, everybody will be able to just pick the self and so on, or send method. But by writing code that doesn't do that, you still can achieve better code. So we already found about mixins, composition, interfaces. There will be types. I will be extending this talk. And I hope it brings you further. And I really would like to get more input from you about the examples I was showing, because this one, it was totally different from the beginning. I got a lot of feedback about how to do it better and how to do the composition better here. It's still not perfect. I would love to get more feedback from you. What do you think about it? How we can make it better to make sure it reads good and it doesn't break composition. So that would be it. There is an article already, first part. I will be writing more about types, about functions, about solid, about free Ruby. So just go in and subscribe to the newsletter. And I'm waiting for questions. Thank you. This example.
Maybe concerning the struct here class, it's not a good pattern for me because it brings more methods from struct class. We don't need these methods in here class.
Yeah, actually. Yeah, actually using struct is considered by some people as anti-pattern. It was just for the sake of simplicity here. But yeah, we could do it with one line more of code with a class or two. Or any other question, we can move to other slides. Or liars.
What about inheritance? How deep is inheritance for you? Is good or bad?
There is.
How many deep layers? Yes.
There is no limit. There is no limit as long as it makes sense. If you are still extending the same thing, like you are building person and you are adding more and more features to that person, and in the end, you still can think of super person, and on the end you will introduce God, and then probably God had another father. So you still can go deeper and deeper as long as it's the same kind of. If it's not, composition. Yeah, composition will be working here a lot better. But if it's the same kind of, then it's inheritance. And I don't see limits there. Usually I don't happen to do more than 5-6 hour layers. It's just where if you do more, you probably could use composition.
You mentioned interfaces, so it's basically about interface segregation. And have you already started like publishing your ideas about having multiple objects describing interfaces, and then maybe modules, and then just extend or include those modules into different parts of your system. And statistically, is there any big or small support of the community of this interface segregation idea?
Yes, so these interfaces won't be the same as you think in Java or any other languages, because it's not how you build your object. It's not you building the object from small pieces. It's to limit the object to the small pieces. So it's a bit reverse. So it won't be the same. And I actually was thinking about that, but in the end, you would need a support from language to get interfaces properly done. So you could think of libraries. I think that reverse thing, when you are just exporting just small part of the object for the needs, what you want to do with it, it's also a helpful step. And yeah, if there is some other things that would help with that, I would love to know, because interfaces, it's just this thing that makes encapsulation work. Like it's extension of encapsulation. You have this big object and you cut small piece, only this is for you. You are not allowed to change anything else. So what we had here with hair, is it 5? Yeah, 5. What we had here with hair, we solved the problem with encapsulation. But what we want to do is to just export these methods to change hair from the person. It could be done either with encapsulation or with using forwarding to the interface. Next question. Okay.
What is your point of view on extending or including modules outside the class? So we have class and include or extend modules outside.
Yeah. This way. Only.
I understand, but I mean, you may include contributor in class or outside from some other piece of code.
Yes, so this is quite often used, and this is something I had struggled with when I was modifying RSpec recently, because you have to reach into the object, so you need to assume there is something, there is a variable, and if the version of RSpec changes, you have to rewrite your code probably or not, but there is a high likelihood that you will probably have to rewrite everything, because if they change the major version, they change the interfaces. And then you have to rewrite your code because you are reaching inside. And in such cases, I think it's important to get back to the authors and make sure they provide interfaces that allow you to do what you need. And this is work with the community. You need to get back to the people who write the code and to work with them, so you don't have to extend, include, because this is hacking. What we need is the possibility to work with what is already there. They need to provide the interface. You might need to wait for a version, and then you write an if. If it was an old version, I'm including something, because I know in this old version it won't change. And then when the new version comes out, they provide you an interface, and you work with the interface for extending it. Does it answer? More question, or is it beer time?
Yeah, actually, I had a small question regarding superhuman in class, and to me it seems like we can't like add a new method called fly because it a bit breaks Wisconsin substitution principle. So we can't use person. We can't substitute like superhuman with person because it breaks fly method.
You can if you define fly on the
It works reverse way. It will be always as a person. So, so if you got superhuman and you know it's superhuman, that person will be flying. But if you are expecting a person, you can put superhuman in there. It will be just fine. Yeah, but it's important too. It's on the list on the solid part.
What they say here is better to use roles because fly is can be role and any superhero can fly or not fly.
Yeah, that you can instantiate superhuman. It's not just one superhuman, it's the class. Then every instance will be separate superhuman.
But if you put another superhuman that also can fly and have some supervision.
You'll have probabilities.
Yeah, so you would be using superhuman only to include the strength, and for the other parts, you probably would have to write composition to make sure the flying and so on is calculated properly. But what we had here with the barber included, this is something what happens if you are trying to do composition. If you don't think about encapsulation, about all the data that is in the object, you will end up with extracting it just in pieces. It goes here, and sometimes you maybe pass a variable to another object and allow it to change it, like a proxy. You have to be very careful.
You mentioned documentation as a part of object-oriented code. What kind of documentation do you think that is enough, or the example of documentation?
Yes, so if you write a method, you have to write what the method does. You need to write what are the inputs, what are the side effects, and this is something I'm missing actually in Yard and current documentation tools for Ruby, because they don't assume that something will be changing. They just allow you to put a big blob of text on top. Oh, we will do that. It doesn't define the interface like we will be changing something inside. But the rest of the documentation, attributes, rises, return, those things are the interface. What's your input? What's your output? If you change something inside, that's the side effects. And this is not supported yet. I will be getting into that with the people that do that. It's quite easy to extend Yard. I already did some extensions. You can write more of your own methods. So it should be relatively simple, like 1 day max work to implement a new parameters that will be describing what's changing in the documentation. Okay. Okay, beer time it is. Thank you, everybody.